Well, welcome to the class. Hi to everyone. Uh, my name is Alexander Prishepov. I'm associate professor at the geography section, and I work exactly in the land system science, contributing both in the teaching of the remote sensing classes, but also on the land use and land use theories. So how we can also showing the students how we can use things together, both remote sensing, but also land use modeling. So that's actually my topic, and I feel very comfortable with today's lecture. So today we will be talking about the land use change models and also how we can measure land use. I work in a number of the topics if someone is interested about both agricultural expansion globally, but also agricultural land abandonment. So we see in many parts of the world also for a number of the reasons why the lands are not cultivated, and we need to do something about this. And a lot of policies in Europe are in fact about suppressing farmland abandonment to use for other amenities such as rewilding. So as a topic for today is land use change models. So we'll have a lecture and you're more than welcome to ask the questions and switch on the microphone, whatever works for you. And we will have our breaks in between. So we will have approximately 2 hours of lecturing with the breaks, of course, and then a small exercise prepared that you explore the modeling part. Well, sorry of not being in Copenhagen, because that's actually my term when I have a break from teaching remote sensing. So I'm based in Germany. It will be a little bit unwise, put the carbon and flying to give the lecture in Copenhagen. So thanks for joining on Zoom. And if you wouldn't mind, I start recording. If someone has some, let's say, questions about it, please drop me the line. That could place later this recorded lecture for you on a Zoom. So what I mentioned that we will talk today, so the topics for today, and please let me know if you see the slides, if there are any technical breaks that I can immediately try to fix or switch the microphones and so on. So we have some readings. First of all, I hope you had a time to pass through these readings. They are not hard, but they go through all sorts of the models, examples of the models people use these days to link pixels and people and evaluate the different drivers of the land use change. What we'll go today is through how can we reveal land use land cover change and with the remote sensing techniques, but I will also pose the question and we'll discuss about other perspectives. And what is the essence of the land use modeling? So what is a modeling by itself? We'll also have some kind of the brief excursus. What should we consider before start modeling? We'll look at the examples of the integrated land use modeling approach, common in the land system science. We'll go through the qualitative to fully quantitative modeling perspectives and examples of the models, how we can do qualitative research and do some assumptions about possible drivers of the land use change, then going slightly into the descriptive statistics analysis, such as a meta-analysis, and then to fully quantitative approaches, including regression models or structural equation modeling, Bayesian networks and such. And then we will also contrast the different scales where we apply the models, such as the agent-based model when we go at the farmer level, for instance, or global dynamic models when we look holistically at the whole system as a dynamic and how things are interrelated across the continents. And last but not least, we will also address how integratively use modeling approaches in addressing complex research questions. As a learning outcome for today, I believe it will be really important just to have a kind of the sense about the modeling. We don't expect that you will be doing the modeling for now, but maybe in your future work, or you will deal one way or another with the have a modeling outputs or modeling exercises. Even at the municipality level in Copenhagen, we need to do some projections about, let's say, change of the population dynamic or some structure, and some models can be run pretty neatly and fast. And also being able to identify as a geographers of the relevant data and models we can use for specific tasks and the scales. Well, if to think about the land change processes at the glance, I mean, the questions are now at our table about land cover change. Even we don't need to walk far away. If you see through the news in Denmark, there is an ongoing discussion about how to offset the carbon. And it's a strong debate how it can be achieved, and one of the possibilities with the increase of the forest. But once we think about the state of the forest, we usually think, okay, there is a forest increase, but we need to know what kind of the forest is that, and what other processes are taking part at the same time. We may have both ongoing afforestation, but also the processes of the deforestation. So thinking about Denmark, do we have just a forest gain for the last years? How much we have it? More forests, less forests, the type of the changes and trajectories and the rates. Do we get more forest across sometimes, or if it's like a high pace, or we still there's some slow pace of the forest gain? And these questions we can address as well. Thinking geographically, it may also represent very different degrees of the patterns. So we may have different areas that can be susceptible for forest increase and forest increase, but also the productivity. So this is also we want to disentangle, not just to have a number that the forest gain, but also we need to know where this forest gain occur and where it might be opposite process taking place with the forest decrease. And maybe these processes can be geographically interconnected even at some distance. So that's in total, once we discuss about the forest chain, in example of Denmark, we observe that for now we observe a forest gain and it results in some carbon removals. So that's questions we would like to address. And this is primarily done these days with pretty neat approaches. So almost a rapid assessment with any satellite data which come for observation. An example of the Global Forest Watch, that you can zoom into any of the country of the world and get some statistics about how much is the forest covered, how much it may be gained, and type of the forest. So that information these days rapidly come with the use of the satellite data. Thinking about the land use land cover change, and we use it interchangeably, but in principle, it's a very important notion, because for now, there've been a lot of studies with a concentration on a land cover. So in a biophysical state of the world, you may come across different products which map forest cover or grassland or bare lands. So basically what represents the terrestrial land cover. But often we would like to know how these forests, for instance, are appropriated, what they are comprised of, not only the species, but also land uses. So some forests can be in the intensive logging, and others, they can be placed on the plantations. That also represents different types of the forest, from the quality and also applications. And if the native forest is replaced by the plantation, probably that's not something what we envision about natural components. The same we can think about impervious surface, which is a common land cover class. But once we zoom in into that, we can identify that it may represent urbanization, not just like a bare soil or something, but something what converts and appropriated by the humans. And this is exactly what we want to know and better understand the processes of land use land cover change. So the question comes then how to obtain this information. And nowadays, we pretty much rely on this whole suite of the so-called satellite remote sensing. So we use a lot of sensors placed at some distance, which allow us a little bit unbiasedly and in a rapid fashion observe the changes around the globe. That's the whole idea behind that. We need something to have that allows us systematically record across the large area. And the best way is to place some maybe sensors into the orbit, into the satellites. So then we can collect this information, digitally record that information, process, classify, and produce land cover change maps. So remote sensing was already with us for quite some time. In our eyes, even my glasses and my eyes, it's also sensor. The only difference is that what we have in our satellites or aerial photos, and back even more than 100 years ago, is that we want something to store. Yes, or what I say with my eyes, probably nowadays with some digital cameras, we can record that as well. But we want to have, first of all, something at the distance to see a large extent, but also systematically recorded. And this is where the strength of the remote sensing came into the power for quite some time ago. And remote sensing plays a fundamental role in the land cover change, and we that observe as well in studying the drivers. That slowly we go into the modeling component. We can use, depending on requirements and knowing the pros and cons of a satellite remote sensing, something is what is in the orbit and can repeatedly record information across large distances. Or we can place the airplanes or helicopters and record the a little bit smaller extent, but with more details, with more instruments. So that brings the advantage that we may have, such as for Denmark aerial photos, observations, but it would require a little bit more efforts, a little bit more investments, and it will be still for not as large as beyond of the Denmark or Copenhagen. And then the same with the AOV, so unmanned aerial vehicles, so the drones as well, that we may get even at the couple centimeter data, and with a lot of details, but surely it may cover a small extent. So also limitations of the capacity of the fly with the drones. So it brings both pros and cons, and there are a number of the ways how, of course, we can benefit one way or another, or consider or prioritize, depending on what we want to study to link to the land change processes, one type of information of another. The systematic records of the satellite data, in fact, they go back to 1960s, and with aerial photos, we can go even early 20s. And I did my PhD in the United States, and we used some photos with the land cover reconstruction back to 1920s. Pretty amazing how much information we have. But with the systematic observations, and one of the workhorse, it's a so-called Landsat program, goes back to 1972. So we nowadays have repetitive observations, and we can reveal different processes around the world. And one is, for instance, the forest cover change. Landsat allowed to reveal these fish-borne patterns with the global deforestation in Brazil and Amazon back to early 90s, where the scientists became really concerned about how quickly forests are intercepted with the agriculture once the roads are built and so on. But also we start noticing other forms and connections with the land users. And pretty exciting times we live. You hear a lot about machine learning, and even the University of Copenhagen has a lot of debates about ChatGPT. But what it allowed us to do with the machine learning is to use all archives from Landsat back to 1972. And as a colleagues from University of Maryland, Matt Hansen group, they mapped with the Google Earth Engine cloud computation forest cover change with quite in a dynamic fashion at the 30 meter resolution all around the globe. And you are more than welcome to click and zoom in, zoom out, and download this data. So that's where the power comes with the satellite data. First, if any group can get this data, process, and put their own maps, depending also maybe on some definitions. So we can always retrace and reprocess this data with maybe new algorithms. But since this data is also public, then this data is also becoming public and become a strong power for decision making. And I'm a little bit also part of the so-called NASA Land Use Land Cover Change program, which is actually linked a lot with the land system science. And please be welcome to explore. There are a lot of very nice webinars with the key scientists around the world who are working in an integration, studying land cover change and drivers, and they put the webinars online. So you can watch some of them about different processes like mangroves, agriculture expansion, or urbanization. So this information is publicly available online. Well, these days we have more satellites. That's we started with the Landsat, and there are aerial photos as well. And combination of them allows to look at the different components. Each satellite has its unique characteristics. Some they look through the clouds, such as the radar data. And altogether, the synergy or the fusion of the data allows us to address the complex questions at different scales and repetitions also, how often there's certain sensors that overpass the areas. We think about the satellites, and to reveal some land cover change is one of the sources of information, I should admit. But we also should consider different limitations they have. And one of them, of course, the resolution, resolving power. And among them is a special resolution, or it's called pixel or picture element, how in details we can observe certain type of the land uses or land cover. Well, if we add the 1 meter, it's a National Agriculture Inventory Program, NAIP program from the United States, and we have similar aerial photos for Denmark with the public access. So you have quite a lot of details. You can go even at the level of the individual trees, what Rasmus also did for his PhD, linking the trees and the diet. And at the same time, we see some sort of the details, but sometimes maybe we don't need that many details. And again, there might be limitation about the extent of this area. While if we move through other type of the satellites, such as the Copernicus Sentinel-2, which is the mission by European Space Agency, it's a freely available data at the 10-meter resolution. We see it's kind of the trade-off about the resolution, but also it gives us almost, if we combine all imageries together, even at the subcontinental extent. So it would allow us to cover large areas. And Landsat goes at the 30-meter resolution, so we lose, again, some power to recognize something, but the essence of that we have also temporal component going for the last almost 50 years back in time. So if we want to achieve almost as a daily observations, and maybe even twice a day, then the compromise comes that we will have a coarser resolution, but then a snapshot around the world. So this type of one of the limitation as a spatial resolution may determine our ability to distinguish something, and of course applications in land change studies. So we need to think quite a bit before once we use this data, what to expect the same from the Matt Hansen group. What can we recognize at the 30-meter? Once we think about the satellite data, it's nothing else. It's a digital information stored with so-called pixels, or picture elements, and each pixel has certain number. So digital number, which is connected to specific reflectance of the object. Again, this is how satellites are working. So they try to record in different sets of the spectrums, including visible, how we see with our eyes, but also so-called near infrared, which corresponds very differently to the different degrees of the vegetation. We don't observe with our eyes, but in that sense, this set of the spectrum, we can record more meaningful information about the state of the vegetation. And then our task in the end is to train algorithms. So basically provide, if we know some areas, we can provide the reference data and use some mathematical algorithms, automatically train algorithm based on these examples to classify, to produce the maps based on the reference data we provide. So for instance, if we know that specific field marked with the yellow is agriculture, it may have very unique spectral characteristics, and the same to the water. And then providing this information for the algorithms may automatically classify and produce for us land cover maps. And that's what we teach in some other courses. So that's, you should not be worried about it, but this is when you see maps of the also Matt Hansen global forest cover change. This is how they produce. They have some reference data, they'll extract information from satellite data, and algorithms, they automatically classify and produce the maps. So in general, if we think about the flow, how we produce our data, for which purpose, before moving to the land use models, first, we would like to address how land use, land cover change over the time, and where these changes they do occur. And we can notice for the satellite data, let's say we had some forests or maybe mangrove areas, and they were deforested and converted to something else, let's say to agriculture. So also what type of the changes we observe. So these questions, remote sensing helps us to address. Yeah, so we know the patterns. So also we know the pace, how fast things are changing, and type of the transition it goes. But land use models, they help us to answer other types of the questions when we start linking pixels and people, and primarily why these changes occur. And we will look at later at the sense of the drivers. So what drive these land cover transformations? As an example of we'll look at the case study now with the mangrove change, and why it's important, because it serves for different ecological function. So that there are some global maps with the decrease of the mangroves in many parts of the world, and they serve both win-win situation, both for the environment, carbon storage, providing nutrients for the dependent fish and species, but also serving as a buffer to protect from the flood events for population. And as a typical flow chart, if to take some of the studies with the, let's say, mangroves deforestation and the role of the satellite imagery, and before proceeding toward studying the drivers, to obtain the satellite data, there are specific tasks to pre-process, combine, harmonize the imagery. And then we have some data, we know about some areas, so reference data or ground validation data, ground truth data. It can be done visual interpretation of the land use, land cover change, or automatic classification. So we train the algorithms to produce the maps. So we do some kind of the, based on the satellite imagery, interpretation, either manually or automatically, and we come with these maps for different period time steps. And here, for instance, Landsat imagery was used, which allowed to go back to 1977, almost half of the century ago, and start observing these transformations for key periods. And then based on that, we can calculate all sorts of the statistics. First of all, to know the patterns of change, where do they occur, rates of change. There might be some maybe policies specifically placed to protect the mangroves that would decrease the rates of change, and also allocating land cover change hotspots, and generating very important output for next thing is to study the drivers of change. So that will be a common flow with the satellite imagery to work with before we kind of bring the data, how we produce the maps, and before going into the drivers. And that's example we may reveal nowadays with the satellite data quite dynamic, almost on an annual basis, maps of the state of the land cover mangroves and how they transition to other classes and really even the pace of change. Now I arrive here with a slide, and I would like with you to a little bit discuss if it will be possible. We see the satellite imagery, and I briefly mentioned, but what might be potentially pros and cons? Maybe sometimes you use a Google Earth and zooming in, zooming out. What potentially you see the advantages and potentially see disadvantages of using a satellite data? Because my role is not to advertise remote sensing, rather opposite, to be a little bit critical about the technology and what other techniques we can use in order to reveal land cover change. So let's maybe chat for 5 minutes about this. So please, if you have your microphone on occasion, just step into the discussion.
I was thinking that maybe there's a lot of things that you're missing. If you have something on a 10-meter scale, there might be some smaller changes that could be important that you could miss by using only remote sensing and not really being at the location.
That's true. We sometimes call small geographies. Could you, maybe you can bring some example?
I don't know if, because I think we've actually solved some of those problems. I was thinking about trees, for example, but we solved that, I think, at as I didn't participate in that one, but somebody at KU solved that one with the trees. But I think there could be other places where you might not have that type of resolution. I'm not sure if it's an actual problem or just something I was thinking. So
that's true. It's a really good point. It's a really good point.
If you're studying something and you only have access to 10-meter resolution, in that specific study, it could be a problem, but it should be possible to find like 2-meter resolution as well. And then you have some problems with privacy, because if you have a 2-meter resolution, you might be able to see stuff that not everybody wants you to see, probably. Like you're invading people's privacy.
It's Camilo, you brought a lot of sets of the very valid points, and let me very shortly to elaborate. You brought exactly about that the resolution really matters, and we may miss some so-called small geographies, and trees are among them, and maybe other factors as well. Unfortunately, the question, of course, comes that sometimes a good data is available maybe for recent periods from like commercial satellites. And if we look back, we actually really becoming surprised that how much data is being recorded one way or another. In some way, it just simply sits somewhere. But some areas are simply not privileged to have this type of the detailed information. And this is where we need to get the compromise with the 10-meter. So one is, it's a field has been developed by itself by social scientists. It's called critical remote sensing. So first about the access of the data, that not each institution has access. Private companies, they play a fundamental role. They are not allowing to disseminate these maps because they sell data. And that's why agencies like a European Space Agency and Lancet, it's a USGS, they're coming with the free data, but free comes also a certain way of the trade-off. And then, of course, about the ethical questions that if you place this type of the information on a timely fashion, it may bring all sorts of the problems as well. But one is probably critical that we still observe the lack of the very high resolution data for now, and so on. Thinking about also resolution, does it really matter? You may consider about the temporal component. If we have agricultural fields, do we need to have a high resolution data, which would be maybe recorded once in a while, or would be how would you consider What is more important, resolution or spatial resolution or temporary resolution? Probably a temporary resolution will be very critical, let's say, the crop conditions. And in that way, we can maybe say, okay, we are fine to have 10-meter data because the fields are really large, but rather, let's say, not daily, but once in 2-3 days, we'll have some recordings about the progress of the crops. And that's why also certain sensors are designed for these purposes to monitor, let's say, the state of agriculture. And we can see potentially our applications, but also which data we will prioritize for one study or another. If to study, let's say, food and diet and trees, probably if there would be some change, we will observe this change maybe once in several years. So it's fine to have one observation per year. While we study agriculture, it's very critical to look at the development of the crops. And that way, we are more prioritizing temporal component. And unfortunately, sensors, the way how they're designed, you cannot have all at once, both very high resolution, but also temporary visits. The another question also comes, of course, what I mentioned, that even we are privileged to have for 50 years, but how about longer time span? And my question would be, do you potentially envision other source of the data which would be potentially useful for land cover change studies? That's a question to everyone. If you maybe were coming across other sets of their data. Denmark, I think it's also a privileged country. We have one example of the records about the land surveys or historical books, church books. They have all recordings about parcels. If someone wants to step in, it's fine. I will just wait for 15 seconds or so, and then otherwise a little bit elaborate, and then we'll move on. We can use also agricultural statistics. So even what information comes and collected from farmers or statistical offices, the only disadvantage would be is that it's aggregated data. It comes at the municipality level or sometimes in best block level, information about land uses. This data is also used in our land change studies, and there are models built around. There might be point-based observations. Someone goes and does the surveys, let's say farmer, with the recall of their land uses. As a Cecilia and some of our colleagues, they used quite a lot. You can do backcasting also, looking at the land histories where the people look about land users. And I believe one of the papers I was reading also for this class about how people interpreted remote sensing data with the participatory approaches. That's also the way how the people, scientists, they placed on a map land users and the people, where they just some aid of the satellite data, but primarily information comes about the land users from the recall of the farmers, of the decision makers. So not only remote sensing is used for, that's the most important for land change studies, but any data which has a land use history component been systematically collected. Of course, often it comes at a much smaller scale, so smaller areas compared with what satellites they can provide. Okay, so with this, we go to transition. So we obtained our land cover change maps, and we want to understand the most important, what actually brings our curiosity, not only what is changing, but why. And that brings another sense of so-called modeling perspective. And when I think about the model is never ideal. That's the most important. And the model, no matter which model you will choose, is just a the best possible plausible abstraction of the reality of the world and of the land change processes. It should be plausible enough, but it will not show you the whole complexity, for instance, of the driving mechanism behind to the, let's say, mangrove removal. And if anything we need to know before they are going into the model in the drivers, one, of course, what kind of the data we receive from the satellite imagery, ability to distinguish something will determine also our ability to model the processes, but also how fast things are changing. We may also think about the special contexts, or if we look at the local scale studies, regional, national, or international sets, we will prioritize one model or another, or one set of studies or another, and modeling approaches. And the same perspectives of the factors which operate at each level. So if you think about, let's say, individual factors, we may apply one set of the models and also the perspectives and assumptions. Or if we talk about other sets of the factors like a biophysical characteristics and such. So that's something we sometimes think before we make a step toward to the modeling. First of all, of course, what we want to address, our resolving power with the satellite data and scales of our work. But why I bring also what else we need to think about before modeling? We need to know some kind of the driving mechanism behind to the model, the essence. And that comes with the theories. So if, and I'm trying to link also to publication that Peter Fairberg, once he discusses about deductive and inductive approaches, and that often comes, particularly deductive approaches, that we have some idea about the processes and we have some theory or land use theory or another theory which may explain the process of land cover change. And that's my question to you. Before we'll make a small break, what is, in your opinion, or maybe you were coming across about the theories, some theories which may explain one process, land change process, or another? If not, we will probably learn after the break altogether, look and explore both some theoretical settings and also how it has been implemented in a modeling context. Let's make a 10-minute break, so until 10:10, and we will see each other back, yeah? Okay. 1, 2, 3. 1, 2, 3. So it's working. Okay. Now we're getting back so to the part of the theory. So first we obtained our land cover change maps with the satellite data or other types of the information. But if we study the drivers of change, we try, or if we want to understand the reason even in between, why, or maybe start opposite the entire our curiosity and study, thinking about potentially drivers of change and design in the study, we can also think about immediately what kind of information we can use in order to obtain the patterns of change. And also thinking immediately about the mechanisms, how we're supposed to address the understanding of the drivers of change, and thinking about some specific theories. And one common approach is to look so-called neoclassical approach of the profit maximization. And it brings us as a Homo economicus, so we, from economical perspective, we always perceive that we make our rational decision making about any processes of change. Let's say if the farmer is extending agriculture, deforesting some areas, he wants probably, or she wants to expand farming, and there are some maybe very specific reasons behind. And that's what economists, they put so-called profit maximization theory is one. And in social science, it can be life course theory. So something what we do early in our life, we might not necessarily will do late in our life. So some people may put a risk and investment in some farming activity in the frontier when they are a bit in a younger stage, where the people are close to the retirement and doing this type of the investments. So that's what we want sometimes to test, to which degree certain theory fits in explaining some process one way or another, or maybe combination of the theories. And surely if we study some process about, let's say, life course theory, we may probably look only at very small scale, because we would need to interview the farmers, maybe in some way collective behavior at the large areas. So theories really do matter how we later on proceed with our modeling aspects as well. And just bring example, some extension of the profit maximization. And for our exercise for today, we will look where this example of the urbanization and assumptions with the modeling perspective got started, looking at the Fontunian and Fontunian rings. And this is just another extension in the context of the urban landscape. And bringing William Alonso's conceptualization of the urban areas, an example of the rational decision making, well, I place later to which degree it fits to some other context. He looked at the typical, maybe American landscape, urban landscape. So we have a central business district in the center. We have this high-rise buildings, skyscrapers, and simply because the rental, the cost for rent of the land or cost of the land is pretty high. Yeah, so this will be very first priority, that so-called CBD, central business district. So allocation of the business estates will be in the center. At least this is how it's maybe designed in some US cities. So that will form the center, the nuclear of the urban area. The second ring we see, it's representing the so-called zone of the transition. It can be a shopping malls, some places for the amenities where the rental is a little bit lower. You still don't need much maybe to commute to the CBD. So it just around maybe to a certain degree to serve both central business district, but maybe outer areas. And they are willing to pay higher rent. The third surprising set is coming from so-called independent worker house, so the third circle. This is something where people would need to a little bit investment time to move to the working place. And since it's in a city and not much has been left in terms of the vegetation, It's maybe not a super preferential area to live. So it's again, maybe overcrowded areas, the buildings where they live, is a balance between the costs for the land or rental and what they are willing to pay. And what you see later, that so-called comes the zone of the residences, that again, already here, in these residences, people would need to spend the time maybe to use a public transport to commute to the city, and the price goes down, but also you see the buildings arranged with some a little bit space around. Please have a question if you have, or is it me with the, probably it was from my side. And then the classic thing is that we have a zone of the residences, so sparse area, and we have a buildings, and this determines that people would need to spend a little bit more time to commute, but at the exchange they will have greener space. The rental will be to a certain degree low, but since they have a residential area with the larger plots, they will pay still quite reasonable price. So that will determine the landscape. And then for the commuter zone, where the people would need to spend substantial amount of time and also costs associated to move to the cities, in exchange of having the private houses and specific facilities. This would be like some kind of a classic set determined by ability to pay, willingness to pay for a certain type of the rent and being close one way or another, but probably other factors may determine besides of the income level, such as the, again, status, marital status, stage of life. If you want to be close to the amenities, museums, it's very important. Rather having more space for the children, you will prioritize one area or another. Thinking about Copenhagen, well, unfortunately, probably we see that as well. We see that the buildings are increasing in a height, breaking the skyline for residential, but also business areas. And there is a classic way of moving in and out. Once the young families that start having children, they tend to move out to have a bit more space and less noise, to be a bit outside of Copenhagen, but also paying lower price. This is theory. And if we study about the urbanization, we can think about how this theoretical construct would allow us maybe to design the questionnaire, and what kind of the questions will place of factors we would need to measure about the statistical data or with other inputs. And in the end, we also may consider, if we study this fine detail urbanization of in particular city, there will be also selection with one model or another, for instance, like agent-based model to map the behavior. But question I place here, so which factors, kind of the self-address, may determine this land uses, but which factors, in your opinion, may work differently and break this theory? Because the theory is just a really rough assumption how world operates, and there are multiple other theories which cover other aspects of urbanization. Maybe you can witness something in the case of Denmark, and I'm very happy to hear from you. Thinking maybe about the Copenhagen, what we see maybe a similar or different from the classic Willems Alonso setting. Which factors, in your opinion, a little bit shape the way how we observe Copenhagen? Someone would like to volunteer? Well, some hints about. So, yes, please, Anders, please.
Well, I think like in relation to the urban areas, like maybe we have in Copenhagen, for instance, another interpretation of welfare and like economical wealth that like it's another kind of city center, and like I think we don't have the same like residence zone as in these American examples. Like it's a more like a sign of status to live in like the crowded city.
I believe it's a really valid point that knowing a little bit about the residential context, that also you have different types of the like the cooperative, that everyone has to have a right to have a property and sense of wealth, exactly, the priorities, social priorities as well, maybe degree of happiness, but also zonation, the zoning as well, may shape the patterns. Yeah, I mean that also we have this waterfront thing, so more like from the cultural amenities, but maybe through the years, sometimes we notice things are changing a little bit differently. But these factors, exactly, they may impose different sets of the theoretical assumptions, like the status of the wealth or maybe behavioral factors. And in that way, certain constructs may not necessarily fit well and explain well urbanization processes like in Europe. And I believe, yes, that's a valid point that, I mean, we may notice something with the rental or the costs, they will be there, but other factors may be important as well. Okay, so you noticed before one is a really important concept we use with this Geist and Lampen, and I remember that looking also for the readings you had over this course, you passed through Geist and Lampen, and I like a lot, I use a lot this construct with the example of deforestation, that we think about the land change processes. We think about so-called proximate causes and underlying causes. And bring an example of the deforestation, so forests can be cleared for number of the reasons, such as with the agriculture expansion, wood extraction, infrastructure extension. Also, if agriculture expansion, if it's a small private smallholder properties, or if it's a large-scale investments. And all these proximate causes, what we see immediately with the help of the satellites, may have their own sets of the drivers. And like coming from the demography, so how population structure is changing, or economic factors, how distant and remote or global economic factors, trade may impact deforestation levels. Also technological transformation, you have a larger harvester, you can make clear more land, or policy institutions, if certain policies, they favor deforestation, or opposite, they work well in prevention of deforestation. And also so-called other factors, or predisposing environmental factors, by physical site conditions, proximities, and very importantly, cultural factors, attitudes, beliefs, individual household behavior. In my opinion, the most studied usually factors are predisposing environmental conditions and biophysical drivers. And the reason for that, because this data is available. Yeah, digital elevation model, soil types. And the most challenging is probably to understand policy, institutional economy, and cultural, behavioral aspects, because for behavioral aspects, you cannot rely on statistics. You need to run the surveys and to work with the farmers to collect this data, and it's hard. So these usually drivers are not really, they're a little bit understudied, let's put it this way. But the whole concept helps us to think about which theory also fits well also in explaining one set of the drivers or another, but also if we study also what kind of scale we need to go. And if we study cultural factors, we'll go in very fine scale work at the farmer level, while economic factors or policy institutions will look at the whole holistic perspective, maybe even using the global models. So I brought the slide kind of showing that theories and how we study the drivers, we look at the different scales. And in order to understand land change process, it's not just enough to look one type of the scale only at the sets of the farmers, but we may miss other factors. And in best, we can proceed, let's say if someone has a lot of time, can study in all hierarchical levels. So with the number of the models, number of the scales, or what, for instance, Catalina Munteanu, she did in her meta-analysis, she assembled kind of the collective knowledge from meta-analysis, what has been done on the studying the drivers in the Carpathians through the systematic literature review to show what has been studied so far, but also existing gaps, research gaps as well. Maybe some scales were missed or some questions as well. So for each scale, again, we need to think about the theory, we need to think about inputs and research questions, but also the models we can use for this type of the study. Let me bring some example from my personal work and how we used integrative approach, and you see at which level the work has been performed. So I bring example from my work. I work a lot also in Eurasia with the grasslands in Mongolia, China, Kazakhstan. Classically, I wrote my PhD about collapse of the Soviet Union, how it impacted land use, land cover change with massive abandonment, with the increase and decrease of the also deforestation and reforestation processes. And at some point, we noticed that not everything we can explain with the economic models, and we look explicitly at the one region which is ethnically diverse. It's a Buryat Republic in Russia, and we look at Selenga River Basin also in Mongolian part. And the region is where Baikal Lake is. So it's a very beautiful area. So the lake is one of the pristine freshwater lakes in the world. But this area represents also a very diverse combination of the nations. So like, for instance, Buryat, they are sort of the descendants of the Mongols, so more like an individual entity. And they are primarily linked, what we assume, with the livestock herding, less with the crop production. They are Buddhists, so something we assume also related to religion attainment, that religion is not in favor of the cultivation of the land, and they have their own amenities. Then Soyots, they are more in the north of this region, so they are practicing reindeer herding. So it's very extreme conditions from steppes to the almost not tundra, but taiga region. And then Russians is collective term. It's not like really Russians. So there are Russians, but also called all believers. So those who are sort of in exile for the religion split, and they have their own also sets of the farming characteristics. And the question was that after the collapse of the Soviet Union was a massive abandonment. And massive, it means 70% of the land being stopped cultivated. And of course, government want to, at some point, was to return back in production. So we wanted to look at the behavioral aspects, to which degree behavioral, also perception, the corruption and other factors could determine the willingness to put some risks and start cultivating once abandoned lands. So with this, first of all, in the statistics, you see how things are quite diverse with the change, like how Soviet zone areas, so croplands, they declined up to 90% in some districts, completely stopped use as the crops. Livestock was above increase, more in the north, and decrease more in the south. And population was also increase and decrease in these areas. So that also made us kind of interested about to look at this variation. Once you see variation, that most likely also explains some land change processes, what we assume. And we went with a survey. So we had some qualitative part, first of all, focus group interviews, and then we designed the survey, and then we ran the statistical survey. So interviewed the farmers with the sets of the questions, and then we put into the model called Bayesian modeling approach, which has advantage that It has both graphical component, so we can build this model and evaluate the strengths of the relationship. So, and some experts can participate and say which links are plausible or not. And it has also statistical component where they're all coded information from interview come. So we can measure the strength of these connections. So information also comes not only from interviews, but also geospatial data about soil quality, so precipitation, other characteristics, and just quickly help with the interpretation of this model that you see that intention to increase the farmland, so willingness to increase the farmland was related to, first of all, different types of the land uses, primarily not for the grain production. That was a surprise. That it was linked with age, so younger, so from 20 to 40-year-old people, younger farmers could invest and bring this land into cultivation. And that was very important because this area experiencing aging. So more people are becoming aged, so younger they're moving out. So there is some chance of this lands in the end to be cultivated pretty low. So despite of all governmental efforts. Other factors were interconnected also with the perceived corruption. So that was became quite a valid factor and related in general intention to recultivate. So those people who don't believe in the institutions, they will not put into the risk of recultivation. And also with the areas such as with the different degrees of the precipitation, so with the better conditions of the soils, they've been appearing as well in this model. So here we see, first of all, the model maybe would be representative because we run across this large region, maybe for the region by itself, in thinking about the scale, but also as a geographers, we see that these variables, they come in at a different level. So we have both climatic data, we have a farmer characteristics, individual characteristics such as the age, farm data also about the some productivity and so on. So, and it's a dynamic model, and instead of like in agriculture economics looking at the one aspect, we look holistically at the whole system, and that's what we call land system science, looking all together in these factors. So how it can be done further with this model? So that's, we sometimes think about how land use, land cover change. So this question was addressing more how things, what are the drivers are, so what the reasons for these changes or potential changes, and to place into the perspective the landscape transformation in the future. We can also dynamically and holistically assess with the integrative modeling approach, estimating suitabilities, for instance, which areas can be prone for the recultivation based on the models. Land demands, yeah, this can come usually from the scenarios, and I will touch this topic as well. Also, potential trends, if we see increase, decrease of the population, also younger farmers, if it will be less likely something will be recultivated, and specific also preferences for which proposed the lands can be recultivated. And some other technical factors such as the conversion rules, neighborhood effects, land use characteristics. So this all kind of presents for us in a dynamic fashion to predict potential changes. One important component is so-called scenarios. So when we think about the future, because first we have a land cover change, we estimate something back into the time, because that's what remote sensing provides. Then we get the sense about the drivers of those changes, and then we need to make some assumption how things will be in the future if we want to predict with our models. And usually we use sometimes scenarios, and scenarios are so-called hypothetical, but sometimes also extreme storylines that we can use some kind of storylines, both text, parts of the text, or maybe some forecasts like IPCC scenarios, and to convert into the measurable part. And usually it's done also sometimes through the workshops. So we sit with the decision makers and farmers, and we ask, okay, what would be your opinion? How things will look like if, let's say, will be bright economic future, this region will flourish, government will put more money, what will be, in your opinion, in terms of the yields? And they will say, well, if the government will put more into subsidies for fertilizers, our yields may potentially increase based on available technology by this %. And could be, so that will give us this measurable part about inputs about the yields, but also expect yields by themselves. And can be opposite, that we can present so-called not bright future, but green future, and stating, okay, what will be if economic factors, conditions will decline, isolated states, how things will look like in the future. And you could say, well, if they will cut the subsidies for fertilizers, we will probably reduce our yields by this amount. And then you put these numbers into the models, and you have an economic quantitative estimate of the output. So that's exactly how we did in a number of the works, and I provide examples. We critically evaluated the storylines through the scenarios development of with some numbers, but also we could use IPCC scenarios where they would state how much precipitation is going to be for a particular area and put into the model. So if we expect less precipitation, then this model will dynamically show a decrease of the intention of the recultivation. But that's a scenario, is just the one as a snapshot, but definitely things can go differently. And with the case of Buryat Republic, that's exactly things went quite in many ways differently, more into the high extreme economically adverse conditions because of the war, engagement of Russia in a war in Ukraine. And Buryat became a region where a lot of people went into the war, so a lot of deaths, and we don't continue work there, but we would expect there will be substantive impact on the land use. But we could not predict this kind of event, because I'm not a political scientist, and maybe they would tell us, well, look, I mean, how things are going. And then the question comes, exactly, that since we have this type of the storylines, how shall we do then when we produce this type of the scenarios and they are not fully representing full diversity of potential directions in the reality? And the question could be answered in a way that surely we try the best and show one of the directions, what maybe sometimes governments, they need to address, let's say, plausible, but also sometimes extreme directions. And they just showing one snapshot of the reality. That's exactly about the models. They just show also what kind of the factors in general operate, but it might be some also other factors. So also explaining them, our ability to capture one type of the, let's say, reality or plausible mechanisms, but we cannot predict the full conditions, like geopolitical conditions and such. So as a summary, with this case study, so here we see a mixed modeling approach common in the integrated socio-ecological modeling and land system science. We selected the theories, primarily plant behavior and profit maximization with the elements of profit maximization. We collected data from the surveys and also ancillary geospatial data. Statistical analysis has been performed with the Bayesian networks, and qualitative approaches that help us to set the models and scenarios which we used both setting up the model but also developing the projections. And factors that come from different socio-ecological levels. Yeah, if let's say in pure economics, people would test only one set of the factors, we try to look holistically how things are integrated and work together with the geography context, biophysical factors and such. If you have questions about this case study, before I will move to the other models. If not, let me proceed for another 10 minutes. We will have a break, and then I will finish the lecture and introduce a small exercise. So other modeling approaches. And if you look at the publications, Verburg and other assigned publications for this class, we have a number of the ways what I mentioned. We can use purely qualitative aspects, also can use the descriptive statistics and quantitative aspects. And purely descriptive, we can have some sort of the set of the holistic perspective, how things can potentially be connected. Some kind of the flow chart and the flows. When I was a part of this IPBES International Panel for Biodiversity, and we were thinking about drivers across Europe and Central Asia, studying, let's say, agricultural land abandonment, and experts were sitting and linking and discussing about plausible connections between one set of the driver and another, and plus minus also if it's a negative or positive relationship. So that's kind of the expert or approach. A qualitative approach gives a lot also of the sense of the plausible things which can be interconnected and studied further, but also based on the knowledge of the literature, potentially give an overall picture. And this is also model. Yeah, it's a little bit maybe complex that all factors are connected, such as the rural out migration, how it's related to intensification or land abandonment, or population change, human fertility rate, share of the retired people, and then also to land abandonment with this kind of the connections. So it gives like holistic perspective, and it's purely based on qualitative observations. And that's also a snapshot of the reality, that the real world may operate a little bit differently, but with the collective knowledge, we were in total 25 experts who've been working and publishing on land change processes in Europe and Central Asia. For several days, we were sitting and discussing together and giving the report for IPBES. So that's very purely descriptive, sometimes based also on the literature and some prior knowledge, can give us some kind of the insight about land change processes. The another approach is purely descriptive. Sometimes at much finer level, we call it role gaming. So you set the game with the decision makers, and sort of the cards start playing, and they could make a votes about which factor is more important, this factor or that factor, and you simplify the process and select some other factors later, and then you summarize the storylines, what becomes more important or less important about potential factors. And this role gaming is a purely qualitative based, and it gives a good inference maybe in setting up quantitative models, exactly how I was showing how factors are interconnected in studying the potential recultivation of abundant lands in Buryat Republic or some other processes. So they may proceed, they can be a study by itself, that you can summarize this role games with the selection of one factor or another when the farmer they sit all together and say, no, this factor is more important than that factor is more important. Then you remove this card, and then other factors are coming. You can just write a report and say in a descriptive manner, or help to parameterize the models and say, okay, this is where we see plausible connections, and these factors may become important in an econometric model and so on. Another holistic understanding with a purely descriptive analysis is that we think about systems and how sets of the system, they move from one set to another. And that's example of the regime shifts with Daniel Müller and colleagues. They looked at the transformation through the Southeast Asian countries, how different countries through the time, through the land change transition, when went to the one stage to another. Could be example, for instance, there was a deforestation, then lands were, maybe it's part of shifting cultivation, and then at some point the forest returned back, and it's one set of the regime that you always have some sequential events, cyclic events with appear in the forest and disappear in the forest. But maybe at some point someone invests from large-scale company and put this forest and replace shifting cultivation with the commercial farming. So then the whole system moves to a new stage through this bifurcation points. They move to the new stage that it will be only stated commercial agriculture. Every year there will be just a cropland. So that doesn't anymore correspond to this previous land use regime, which was a shifting cultivation. And this is exactly we can qualitatively observe based on evidences and characterize certain areas based on the different land regimes. And land regimes may be also some sort of the archetypes. You observe exodus of the population and land change process, and you put in one category into another. So from purely descriptive, we can move to the qualitative / descriptive statistics approaches. And Catalina Munteanu, I'm very happy. I've been working with her for quite some time on the topics, also with the biodiversity, land use, land cover change. And it's pretty nice study, a neat study in a way that they brought systematic literature analysis, exactly evidences from individual studies, and pointing out what processes have been observed in the Carpathians region in Europe, which is biodiversity-rich region, how much change has been occurred. So it has both, I would say, more descriptive statistics approach, both interpretation, qualitative interpretation, but more one step toward statistical analysis. Yeah, that because you already produce some kind of the plots with the presence of one set of the factors or another. And this is really a common way also having sense about land systems or land cover change processes based on kind of the collective knowledge. So we don't need to run regression analysis, but having a first snapshot based on evidences, maybe reports or the literature or some other inputs which we can use in order to develop this storylines about land cover change processes. The another approach also based on descriptive statistics that you see, it's sometimes we call box and arrow methods. It's a little bit extending what Catalina Munteanu she did is Jasper van der Vliet. He did looking at the processes of intensification and disidentification and connecting to the sets of the drivers. Remember this Geist and Lambin, the same underlying causes, so demographic, economic drivers, technology drivers. So they summarized the number of the studies, they highlighted this, and then start linking to the processes, and thickness X of the arrow shows how many studies they highlighted, one sets of the drivers or another of the processes. It can be also a box and arrow in a way. It can also show us directions, so which processes, how they interlink, and we can also convert, I can recall this Bayesian network model, how factors are interconnected, and can be also based on both expert knowledge or based also on a systematic literature review, how we can set up the model to study. So with this, we move from purely qualitative approaches and descriptive statistics, a common set with the statistical regressions. An example of the linear regression that we have a percent of land cover change. We say have a intercept, we have some coefficients, and we place some correlates. What we assume may explain, in that case, percent of the land cover change with so-called dependent variables. So there could be soil characteristics, some quantitative assessments, yeah, distances to the settlements, maybe population dynamic and such. So we just place the regression. So we trying to explain the ever percent or some other aspect with selected factors. And if you ever crisscross through statistical, maybe some courses about regression, so there are some specific assumptions about like independence of the variables and various regression models in economics, or also in our field we use. They serve for different cases. This is example of linear regression, but if we have very good time series, we can use a funnel regression models. Or if there is like a change, no change outcome, we can use a logistic regression when we study deforestation or deforestation. So inputs usually are any quantitative data, so statistics or structural surveys we run with the farmers, any spatial data or combination of these factors. And the challenge with only what it comes with the statistical regressions, it's very hard to establish so-called causality. So in which direction it goes, ever population change drives deforestation or deforestation results population change. It's one thing. And also the sets of the regression, we don't see how factors are interconnected on each other. We just state that this factor contributes statistically significant, this factor contributes, and such. So that's also a common approach in a land use change modeling, because that's a model by itself. So I will stop probably here. I will, if you have some questions, please don't hesitate to ask. Otherwise, please have your 10-minute break. So we'll meet at 11. I finalize the presentation about the models and introduce a small exercise. Okay, see you at 11. Okay. Thank you for coming back. So let's a little bit chat about the models more. If you have some questions, please don't hesitate to ask. So I will wait maybe for 1 minute about materials before. And just thinking about the models, probably you will notice in some of the publications for this class, you can identify the models, and please be also critical, which sometimes which questions people try to address, which models did they select, what were the inputs, and how did they succeed in addressing these questions. Also, where sometimes what I mentioned that understand really well about the biophysical determinants of the land cover change, digital elevation model, soil type, characteristics, simply because this data is available. And we miss still a lot of studies where we understand the human aspects. So talking about the models, again, to stress that you will see a lot of studies with their statistical regressions. It comes from the econometrics, economic perspectives. They are very common in geography. There are geographic weighted regressions. So the whole suite of the regression models. But they are nothing else but besides of testing what can potentially explain certain patterns. They will often not tell you about the causal inferences, immediately why and which also direction the relationship goes, because the relationship may go one direction or another. Population change may impact land use change, and land use change may impact also the population change. So in some areas, people may come in when it's deforested, it might be opposite. And that would require another set of the statistical models where we can test causal inference. And we also don't see how factors are interrelated to each other. But yet it's very common approach. So we primarily get the correlates, and this is how we treat this. We primarily call sometimes not drivers, but determinants. So a little bit softer term. And driver is a strong mention about something exactly or driving the land cover change process. But for that, we need to have more evidences. So statistical regression is one way to go, and we can regress in the different levels, both at the having information, the farmer level, regional level, and global scale models. But what we can do as well, and I was showing example that we can have both block and error components with the quantitative component as well together. So how factors are interrelated, so graphically connecting these factors, testing the strengths. And here we have different components such as the nodes, variables, directed edges or causal arrows, which show the direction the relationship goes, states, so different values for the nodes, and conditional probability table. So this is statistics which comes from the, let's say, interviews or the surveys or from classic statistics. And there are types of the model. It's called structural equation models. So we have a set of the equation regression models, and we see how outputs are interconnected among each other, or this type of the models as well. And it has both qualitative and quantitative components. Then, what I mentioned, there is also another sets of the models where we look in very detail with maybe very few interviews at the farmer level, and we try to model the behavior of the farmer with agent-based models. So we kind of simulate the decisions of the decision, let's say, of the farmers. We can record the individual characteristics and ask, okay, how they will make a decision about land use, land cover change, moving here or there. And based on the knowledge we learned from this, because this information we can in detail obtain not from many farmers, otherwise it would take a lot of time, but rather thinking about representative farmers for the large population. So we collect the relevant information and trying to model and represent the collective behavior. So our primary will be concentration first to get decision processes of the agents, and also set specific roles based on these decisions. Okay, which areas would they prioritize for deforestation? Maybe, let's say, in certain hills, on certain elevation. And surely you probably noticed that we may get very detailed information about these farmers and decision making, but it will be probably also sometimes wrongly, not entirely correctly to say we will represent the full diversity of the farmers. So they place like some coarse assumption. And usually also the agent-based models, they are designed to represent the behavior for very small area, maybe some landscape context, several villages, something like that, but we cannot say it fully represents the entire behavioral, maybe in a multi-ethnic landscape, or if we have a valleys or the hills, we will need to have representation of the actions from different agents and maybe different models. So there are very specific types of the software which allows us to connect this behavior and to establish the rules and conversion rates, and to model, let's say, if the more farmers, they're coming with the same type of the characteristics to specific landscape. Let's say policies, they favor population movement, let's say migration of the population, like in Brazil and Amazon, then we can, if more population is coming and they will present this kind of the collective behavior, we can simulate which areas can potentially be deforested. So it's kind of a little bit mechanistic, but also rule-based deterministic model we can use. And surely we talk about quite smaller areas with this type of the studies. On the opposite side, we have another set of the models. And they look at the world as some sort of the equilibrium, and different processes can move one system to another. And that results, for instance, in a global biosphere management model, so which is a partial equilibrium model, and simulates various land use-based activities, like in agriculture, forestry, or let's say bioenergy sectors. So the idea that trade, changes in a trade, we can translate into demand. Yeah, but let's say there is ongoing increase of the prices for the biofuels, then we would probably globally search for the areas favored for deforestation where the biofuel can move into, or something related with the livestock, where we put the constraints where livestock could be decreased. And then it can show you in a dynamic fashion which areas can be prone for deforestation or afforestation or other processes. So it includes quite a lot of different components, of course, with the assumptions, both soil characteristics at certain cell. The cell can be 10 by 10 kilometer because it's a global scale model. That can be precipitation characteristics, but also how across the countries there will be an ongoing trade, increase, decrease, and then specific also land cover types and land uses. Then it will show, okay, the certain country has potential preferences for deforestation. So then in this area, in these conditions, there will be demand for agriculture expansion. Of course, the disadvantage could be that it's quite representing a coarse snapshot the way how the world operates, but it gives also a global, just general sense about, okay, what are the policies of the IPCC, of the UN agencies, of the countries, or sets of the countries like a European Union, if they want, let's say, restrict imports of the carbon embedded products, like it can be a forest products or livestock, now European Union imposes. So then it may limit certain demand from the area, and it will be some conditions for afforestation, for increase of the forests. So again, any model is just a snapshot of the world and has a purpose. And here, surely we don't look anymore at the level of the agent, of the farmer. We're interested about in best collective behavior or other aspects such as the trade, economic, and policy. And you see applications below. I placed how this model has been applied, Globiome, in a context of the plant-based food alternatives that could potentially shift in some sustainability questions. So what will happen if we will reduce 50% of the milk and meat consumption and substitute with the plant-based alternatives? So what will be the result, both in terms of the carbon emissions, or opposite decrease of the emissions, but also how this would change the land demand? That may be outcome. Another could be related to climate-related costs with the large investments in livestock production. So if there is an ongoing trend with the increase of the livestock farms, large-scale farms, what will be implications if, let's say, the new government in Brazil will relax restrictions on deforestation placed in favor in the large-scale companies? What will be the factors? Another could be what will be if the China population will be increasing. So knowing the demand where this, let's say, products and embedded carbon emissions will be coming from. So that's kind of the showing you in a dynamic fashion. So we studied a little bit the processes of the global farmland abandonment, because sometimes you just look at that land is withdrawn from the land use, but knowing that people don't change, let's say, the meat consumption, so meat should come from somewhere, and then it will be interconnected through the telecoupling, what you covered in this course, and we will see in which part of the world areas may be potentially deforested. So, okay, by this time we look at the different types of the models, and each model has, of course, pros and cons, and can use for very specific purpose with the very specific theories we can test and questions. But how can we combine them together? And can we? And in fact, we can say yes. And this is where we can see with this integrative modeling approach that we use different components. And we start with various smaller scale areas like agent-based models. So we have limited observations. We make some assumptions based on collective behavior of the farmers. Further, we can interconnect at the regional scale, maybe running some surveys and extending to municipality landscape or regional levels. We can apply any sorts of the regression Bayesian networks, interconnecting this information. And input can be data from farmers, from municipality, or ancillary special data. And then knowing which drivers operate at the landscape and regional level, which I named connected to the agent-based observations, we can make also some assumption in key inputs into global models, like a global dynamic models, like a GloBiome I showed. So in fact, actually, we can incorporate and use one way or another, refining some inputs in the models and in connecting. And what we learned at the very fine scale, projecting to global scale models. But surely it may also bring some sort of the limitations that we have a lot of assumptions for the models, that there will be also some sort of the degree of the uncertainties, what I also show with the different sets of the scenarios. Yeah, so that's kind of the things as the way we are. And as a take-home messages about modeling land use land cover change, so and bringing the context of the land system science, which is an interdisciplinary research field, and compared to strong holistic approaches as in economics, we not only relax, we include the sense of the space and geography and how as a system things are functioning and interconnected. So quite often we use both mixed approach, so often qualitative parts as well. It's it's very welcome to and quantitative methods and interconnection, and show the way how we can use that. And it's also interconnection of the social, natural, and special science. And we use all different types of the data as inputs. So you see remote sensing observations, old maps, historical records, statistics, field measures, and qualitative data. And please remember that any model, of course, it's an abstraction of the complex processes and will be scale dependent. So if we want to understand how farmers interact, we will probably go with the agent-based model, but not with the GloBiome. And if we want to understand the policies, we probably need to go in some other levels to understand the impacts. So we also can do a lot of narrative description and convert them into numbers and put into the modeling characteristics. And models can be based also deductive, so driven by the theory, and also inductive based on some empirical observations, or like a bit in data mining and statistics. Well, modeling is good, but it's just a snapshot or abstraction, relevant abstraction of the world. And let's see, there is now a lot of elaboration with the machine learning and big data and what it will bring us with all non-linearities and a lot of observations. And I'm pretty sure there will be new elaborations and more into the details and showing very complex interrelationship among these factors. With this, I would like to thank you for lecture, and before keeping a little bit time for the questions and answers, and before we'll go and we'll explain small exercise, please, if you're interested, I don't know if Rasmus has shared, we have a community of the land system science. It's called Global Land Program. And you can find also relevant webinars, primarily maybe more on the modeling side, less on the remote sensing. And it's free to become a member, and a lot of events, also early career scientist events. It's a very large community, over 3,000 members there, so it's free. You can join different working groups if you want to study some processes. And many of our colleagues, they are part of the Global Land Program. Me, Rasmus Fensholt, Laura Van Rasmussen, Cecilia Fries, Ole Mertz. So we are part of that. Thank you. Okay, so let me here to stop and get your feedback and maybe some questions about modeling part. Or I will stay silent for 1 or 2 minutes that you can step with your questions. If not, again, thanks for joining this lecture. But let me now explain a small exercise I have for you. I prepared for you, and there is no any need to turn in anything as some report or whatsoever. Rather to explore one of the type of the land use model and do some other activities. Do you see this document?
Yeah, we can see it.
Okay, thank you. So the first part you can also find in Absalon under this in the modules under our week, this document, exercise land use modeling week 23. So it consists of the 2 parts. And one is you can download and unzip the folder called FontTuning. And it represents the simplified model of the Johan FontTuning, which was developed through the TerrSet. And this is really a really classic model. I don't know if have you ever heard of FontTuning model?
Yeah, I think so.
All right. Okay. So that's which you can dynamically play and see the outcome, because that's actually sometimes hidden in many land change studies. This FontTuning rings and profit maximization or land rent. And Alonso's theory about CBD, Central Business District, is just another extension of that. So if you recall, and I place, we have quite a bit of assumption. Of course, this model has been sort of built in the 19th century in a German landscape, and that part, which is quite, I would say, not really rough with the after rain floods. So we have a market, and land uses around this market are determined by the transportation costs and land rent. So, and of course, more you will to pay for these products, and more that will determine the location. So surely we have a dairy farming in that time as a perishable product close to the market, what will also high value on the market. And the second is coming the forests. Well, 19th century still was relying on wood for heat and maybe construction. And then we have afterwards grain and field crops, and then ranching for the livestock is like an outer field. So the assumptions is, okay, there are no any other restrictions, no any trade barriers, nothing, so flat landscape. We just have a market, purely a centric ring, so no any influences of the terrain. And we kind of only determined by these factors. So of course, it's what I described here, that it's a simplification of the reality. So what has been observed by that time, and you are more than welcome explore with this initial setting. So once you download and open exe file, first of all, setting a town for yourself and without the restrictions, and playing with the market price and transportation costs, a little bit exploring about how your land use map would look like. And you can later click on a land use map and also in a rent map to see in a 3-dimensional how land rent would look like. And then some questions just around how you would do if you have a little bit, let's say, orography. You have 2 towns and maybe a cross section of the rivers. So this kind of the things you have, and how this would impact the distribution of the land use. So thinking through this maybe oversimplification, of course, you can maybe also consider how things may change if you consider Copenhagen, what kind of the role of the zoning or change of the priority, the prioritization of the land uses. If to think in reality, this model is implemented pretty much in many studies, one way or another. You see the global deforestation, how deforestation rates and patterns they're connected to presence of the roads and mills, so sawmills. So then this is also a way kind of seen so-called von Thünenwald in a process of land cover change. So just a little bit kind of to play around with this model and see the output. And second part, since I noticed you read my paper on the land abandonment in post-Soviet Russia. So when we look about exactly von Thünen-Riccardin rings, they well explained the patterns of land abandonment further away from the settlements. You have more abandonment than close to that in the factors. But I would like actually for you to be critical, and critical in the sense that the study was serving for very specific purpose and specific scale to evaluate using the Geist and Lambin scheme with the underlying and proximate causes, which factors were studied and which factors were missed, and how well model serves enough and which level to describe land change process. It's more like some critical assumption of the literature because, again, each study has its own limitation, maybe with the data access time and so on. So you need to be critical once you read any research paper, and I bring an example of my case, where you'll spot it on to which degree the study also addressed the potentially underlying causes of the land cover change. And maybe you will spot it on some underlying causes which were not studied, but should be studied instead. So no submission output is necessary, but rather your personal elaboration. So first of all, running a model, playing around how these von Thünen rings will be shaped. If we have other restrictions to cities, roads, in the case if we look about deforestation in Brazilian Amazon, we also have rivers, and these factors they determine the fish pond patterns. But also looking for the literature to which degree maybe a von Thünen is not fully is a good model, or maybe oversimplified to explain land change processes. So more from critical literature look, finding this clear research gaps. I will be here for another half an hour, so you're more than welcome to read, ask any questions. So materials are on Absalon, so please download and let's get started.
Hi.
Yeah, hi.
I have a MacBook, so I can't download the app.
Oh.
And also your article, it was only some of the students here who read it, and then they presented it to us. So I haven't actually read your article. I read another one and then presented that one. So I don't know all the specifics about your article. I would gladly sit down and read it now, but I'm not actually capable of answering all the questions here because of the computer, and also because of the things we had to read for this class. It was just like one of a few papers we had to read in smaller groups. Can I help you with this? One is I can open the model I have on my computer as well, so I can all run together. But another is with the study, if you have a PDF, if you have a PDF, my recommendation is the classic way, skim reading. Skim reading doesn't require much time. No.
You read research questions, then you see a setup of the methods. When I read the papers, I don't read the old papers. Like for this class, sorry to say, maybe I should open up. I look for very specific information. And if it's a classic research paper with some experiment, we look at the research questions. I look at the methodology, if I'm interested, how the methods, and then results. I don't read discussion.
Yeah.
So that's the best way to go, and you see variables. There are sometimes tables. We did also like, this is table, this is variables they use at this level. And then you can immediately connect to the Geist and Lambin, this conceptual diagram. Okay, this factor comes at this level, this factor comes at this level, and this was missed, and so on.
Yeah.
Okay.
Also, I think I'm the only one left.
Yeah, that's actually true. I noticed that.
I know that a lot of students from this class are handing in the biggest assignment of like the whole, like it's the size of a bachelor's, and they're handing in it now, and a lot of people also handing in their bachelor's today. So
no worries. If you want to,
no one's here.
If you want to skip, it's fine as well, because it's complimentary.
Yeah.
If you feel that you also stress about the time to finish something.
My group is actually doing another assignment now, so I think I should meet them, but it was very interesting.
Okay,
so,
thank you.
Thank you for today.
Yeah, thank you for today too. Okay, then have a nice day.
You too. Bye.
Yeah, bye.